coming out. My name is Ben Green, and I'm going to talk about using data to help cities revitalize their neighborhoods. And so this is work that was done at the Data Science for Social Good program at UChicago. You already heard about one other project from him earlier, and you'll hear from Raid Ghani, who runs the program later on in this session. So we worked with the City of Memphis, Tennessee, to help them do revitalization. So just for the international audience out there, Memphis is, if you see the red dot there on the map of the U.S., so it's a mid-sized city in the southeast part of the United States in Tennessee. And so in Memphis, over the past 50 years, the city has pursued a growth strategy where it's really just expanded rapidly. It had lots of unincorporated land surrounding the city, and it kept annexing that land and bringing it into the city. And so in the short term, this was a really great strategy because it was able to increase their population, increase the taxes that they could pull from citizens. But in the long run, this also meant that they were rapidly increasing the amount of land that they were responsible for, and the population didn't keep up. So you see that the land of the city more than tripled in the 60-year period from 1950 to 2010, but the population didn't even double. And so you have a lot of, now like a very large geographic city that you're responsible for, but you don't necessarily have the people to sustain it. And so the city's resources have been stretched really quite thin trying to maintain this large city without the people or the resources to do that. And so you have a situation where you have many parts of the city where what we would call urban decay or distress, or in some places they'd call it blight, but neighborhoods where there's a lot of abandonment, properties are not well maintained, and it just makes for a city that's not very livable. And so the goal of this project was to work with people in Memphis to help them identify how they can invest in the city to best revitalize these types of neighborhoods. So specifically, we worked with a group called the Innovation Delivery Team, which is part of the mayor's office in Memphis. And they're a group of people who's come in recently, and they're really trying to find innovative ways to work on urban problems. So they're trying to find new ways to solve these really complex problems that traditional groups, maybe within City Hall, might not be willing to take on, or they're overworked and don't necessarily have the means to take these new approaches. So they're trying to bring in a way to solve problems in new ways. And so the goals of the city are really to understand how they can revitalize neighborhoods. And so there are a few constraints, though. One of them is that there are very limited resources. The city does not have lots of money, as I've already mentioned. And so it's not able to just go in throughout the city and make tons of investments. It really has to make a few very targeted investments. And so the goal of this project was to help them understand where they could invest money and how they could make a few investments that would have the most significant impact on the city. And a secondary goal was also to understand the broader impact of their investments. So a lot of the time, the city would go in and maybe do something to one neighborhood or one property. And while you can maybe easily evaluate how it affected the value of that specific property, it's a lot harder to understand how it impacts the neighborhood. So they really wanted to understand what's the broader impact of our investments and how can we better evaluate what sort of change we're creating in communities. So we gathered a whole bunch of data from City Hall and different organizations throughout the city, such as property assessments, tax delinquencies, utility disconnections, and foreclosures. And then we also gathered a survey that was done by a group from the University of Memphis, where they went through and looked at all the different properties in the city. And I'll talk about that in a minute a little bit more. But I should mention that all of the data, other than that last data set, all of this data is stuff that's just a standard administrative data that's collected in just about every single city, both in the US and I imagine abroad. And so one of the nice things about this project is that we didn't do any extra data collection. And so from the city's perspective, we were able to utilize data that they were already collecting and already working with and already understood what it meant and how to use it. And we were just finding a new way to use this data. And so this is the sort of work that can be moved in just about any city. We could go in and the same data would be available without any extra effort beyond just gathering it and cleaning it. And so you can take these sort of methods and find them very portable. So the first challenge that we found that Memphis faces is just identifying which properties in the city are distressed and in need of repair. And by properties in this case, we only looked at residential properties, so we're not looking at businesses or anything like that. And that was just dictated by the data that we had available to us. We thought that was the best scenario to consider. So we thought, it seems like a relatively simple problem to understand where you need to invest money and where you may not. But it turns out that while that sort of thing is very well understood at the neighborhood level, I think most people could talk about their home city and say this neighborhood's in good shape, this neighborhood's in bad shape. Understanding on an individual property level where you should invest money is much more challenging. And so if you look at these two pictures of homes on the screen, those are both next door neighbors in a neighborhood that's not in great shape. But you can see that one of those properties is perfectly fine and one of those properties is not in as good shape. But if you were just a city official just looking at neighborhood level statistics, you'd have no way to know which properties may or may not need help. And so past attempts to do this, they would do something called a windshield survey, where they would send volunteers out onto the street, and those people, everyone would walk down some small section of the city, and they would look from either a windshield of a car, or they would just walk the street and look from the outside of the house, and they would try to get a rough estimate of what shape it was in. So they sent people out who would mark every property on a scale of, say, 1 to 5, just saying it's in good shape, it's in okay shape, it's in really bad shape. But as you can imagine, this is a really expensive and time-consuming process. So it's not something that a city wants to do on a regular basis, if at all. So we thought to ourselves, there's got to be a data-driven way that we can recreate these same results without having to send people out onto the streets. So the first thing that we did was we built a random forest classifier based on all of the administrative data that we'd gathered to identify which properties were in good shape or bad shape. And so we used two categories, just distressed or not distressed, and then we were able to look at the class probabilities and use those as risk scores to evaluate which properties were most at risk of being distressed versus not. And so even though we were using binary classification, we're still able to rank our results in a pretty nuanced way. So we have a clear ranking of which properties are most at risk versus not at risk. And so we used many different features, such as the age of the home, the value of the home, whether or not it's had utility disconnections, if there have been a bunch of foreclosures in the neighborhood, and as well as some larger neighborhood level statistics from the census. And so we had a lot of different data that we were able to pull into this. So we evaluated our model in two different ways, using fivefold cross-validation. So the first was just to look at the area under the curve of an ROC, where we got an average of about 0.8, so pretty good results. And then we also looked at how our risk scores correlated with the actual probability of being distressed. And so what we did was each circle, you can see here, represents a group of properties that have been all found to have similar risk scores. So we're a group of properties that we all think have a similar likelihood of being distressed, and that's on the x-axis. And on the y-axis is the actual probability, the actual fraction of those probabilities probability of those properties that were distressed. So you can see there's a very high correlation between the risk score that we're assigning to probabilities and the actual probability that those properties are distressed. So our predictions are clearly able to give a pretty good sense of the condition of different properties. So using this model, we were able to build predictions for every single residential property in the city that you see on the map here to the left. So each dot there represents a single property, and the colors represent their condition, where green is very low risk of being distressed, and red is very high risk. And so this allows city officials to see first at just a high level, what are the different conditions in the city, and then furthermore, on the right now you see, unfortunately in weirdly bad shape, so we built a website where there's an interactive map on the main part of the screen there, where users can zoom in and out of the map, look at individual streets, and click on specific properties to see our predictions for that property. And so they can look at neighborhoods where there's a mix of good and bad properties, and so they can then see which properties are in good shape or bad shape and identify which ones are most likely to need investment and which ones they should look into further. And so this way, instead of having to walk the entire city, consider all of the different parts of town, now they can go in, look at the map, identify just a few key hotspots, and within those hotspots, just a few key properties that may need some further work. So this really makes that part of the task much more efficient for them, just identifying where they should consider investing money. But that certainly does not solve the problem. The next thing that they have to consider is what they should actually do with these properties. So there are a number of different things that Memphis will do when it's encountering these distressed properties. Typically, it either demolishes the home, just if it's in really bad shape, it might just tear it down and leave it as a vacant lot, or it will try to rehabilitate this home and then sell it so that someone new can live in it. But that brings its own challenges because it's pretty expensive to just rebuild or rehabilitate a home. And even when they sell that property, it doesn't make up the same amount of money that they spent repairing it. So that ends up just losing the city quite a bit of money. And so that's something that they like doing because it seems like it's, previous studies have shown that rehabilitations can improve neighborhoods and are good for properties, which makes sense. But it's also expensive, so not something that the city can just do all over town with all the properties. And so furthermore, we also don't know how these different actions will impact neighborhoods. So, maybe demolishing a home or rehabilitating a home, you can measure based on the property value what it does to an individual property, but it's much harder to know how that impacts the neighborhood. So maybe a certain action really improves neighborhood well-being and neighborhood property values, or maybe it has no impact and each home is really just kind of in a silo in terms of how they impact each other. And so that was the next thing that we really wanted to study and help the city understand how their actions will impact neighborhoods. So first, we just looked at some descriptive statistics, trying to find some correlations where we found that distressed properties are correlated in their neighborhoods with lower property values, extending quite far away from the property, up to at least 1,000 feet from that individual property. And as you might expect, more severe forms of distress are correlated with lower property values. And then furthermore, we looked at correlations between properties that had received some form of rehabilitation, properties that had been demolished, and properties that had received no treatment, where we found that properties that received rehabilitations increased neighborhood property value, or were correlated with increased property values. Demolitions were correlated with decreased property values. And so this gave us some interesting initial insights where it seems that our initial hypotheses about rehabilitations being good and demolitions being bad, both for individual properties, but also for neighborhoods. It seems like there's maybe some relationship there. So we wanted to dig in a little bit further and try to understand the actual causal impacts of rehabilitations. So, we've talked a lot here at KDD about A/B testing as the gold standard of trying to, understand causality and really having these perfect trial and control groups. And obviously, in a real-world setting like this, you can't just necessarily, create an experiment where you make some interventions in one place of town and not another part of town, and then try to understand what happens the way that you can sort, users of a website into two different groups. So we have to kind of look through the past and try to find a reasonable natural experiment to understand how interventions are affecting property values. So we defined a trial and control group, where our trial group were homes that were within 500 feet of a rehabilitated property that were recently sold. And our control group were similar properties that were not near any property that had been rehabilitated. So to clarify, the properties that we're looking at in our trial and control groups, none of them have received any treatment. They're simply in the neighborhood of other properties that have received treatment. And so the goal here is to understand, for recently sold properties, if there's a difference between those that are near properties where there's been an intervention versus those that have not been near an intervention. So we found, with a sample size of 200 pairs of properties, we found that there is an approximately 3% increase in homes that were within the neighborhood of a rehabilitated property. So that would mean that if you rehabilitate a single property, then we expect that there would be a 3% increase in the value of a home within 500 feet of that property. Unfortunately, because of the small sample size and some of the other issues with the data, we don't have statistically significant results. But we still think this is an important result to provide to the city, largely because if you're working in public policy, you don't necessarily have the luxury of waiting to make decisions until you have some statistically significant sample on your data. You kind of just have to work with the best that's available. So so we still provide this estimate to give a decent sense to the city of where they should be, how they should understand what the impact of rehabilitations are. So I'll just quickly go through this. We then tried to help the city understand where they should be investing money and what would be the neighborhood impacts of investing money. So we built a website where they could go through and select any property in the city and try to predict how rehabilitating that property and then changing the value of that property will change the value of other neighboring properties. So the goal here is to help the city understand which properties, and if they can only make 1 or 2 interventions in a neighborhood, which properties in the city will lead to the greatest neighborhood impacts. So not only will they reap benefits from increasing the value of a specific property, they'll also see increases in the value of a lot of neighboring properties as well. So this will help them kind of triage and understand where they can have the most important investments that will have the biggest impact. So just to summarize kind of what we built in Memphis, we have, now for the whole process of revitalization, first they can identify where distressed properties are, they can evaluate the impact of different intervention that they're considering, and then they can identify where they should specifically be investing money. And so this will make their process of revitalization far more efficient and effective for future work. And I should also want to mention that, again, all of this work was done without gathering any new data. And so this was something that we're using data that the city had already collected. So it doesn't require really any extra effort on their part. And so just before I conclude, I want to mention some of the lessons that we found while working with cities to do data science. So people have talked in the keynotes yesterday and today about challenges doing data science for businesses and doing data science with natural scientists. And so there are some different challenges that come up when you're doing this with governments. And so the first challenge that we found was that it was really hard to actually work with the city to identify what we actually wanted to solve. So they had really broad goals, but ultimately you had to kind of narrow it down and say, okay, what are some really specific problems and where are some problems where data can actually help us? Many of those goals that you have might be best served with other techniques. So we had to work with them to understand where data could be effective. I'll skip through some of these. And then really another one that we thought was really important was just understanding what metrics you actually have available to you and what you want to measure. So for our interventions, we mostly were evaluating actions based on how they impacted property values. But ultimately, that's kind of an unsatisfactory metric for a city because they can't consider just property values. They have to consider community and social well-being. So it's important to think about measuring what is most important as opposed to just what's easier to measure. So I'll leave these up, and thanks for listening, and I look forward to your questions.
Okay, so we have time for one question. Oh, yes, lady in the back.
Who's funding these rehabilitations?
There's a mix. So oftentimes it will be the city government through the housing office or the innovation team that we worked with. There are also a lot of community development corporations in cities, and so they're often locally based in specific neighborhoods. Well, they'll try and go through and reinvest in 1 or 2 properties a year and then sell those. So we are also working, some of the tools we built were also for them to identify where they should be investing money.
Right. I mean, the reason I asked this question is because instead of looking at residential properties, as a policy planner, why will I not think of, say, investing in schools or any sort of public goods or economic revitalization rather than thinking of residential revitalization, because that is something which could follow as a natural result of, say, rehabilitating the school as a good school district or bringing in work into that area or, a million other things. Yeah. So I'm just surprised at the focus being residential revitalization. I guess that was the question.
Yeah, okay. So, I think all of those, there are lots of different dimensions to neighborhood revitalization, and I think all are important, and I think, understanding the causal links are difficult. I'm not sure you can say that one leads to the other or the other way around. So, in this case, we chose to work on residential properties, but I think that you could also do a very valuable study looking at schools or something like that. But I think I don't think you'd solve the problem just by looking at one or the other. So we took one side, but it's important to look at all of the dimensions.
Thank you.
So let's thank Ben again.